Rice is one of the most consumed cereals worldwide. Approximately half of the population has as a food base. This cereal occupies the third place worldwide in terms of areas planted with cereals for human consumption after the wheat and corn. Is a crop considered a tropical species? However, it is adapted to different ecosystems. It is cultivated from sea level to 1,500 meters of altitude at the national level, due to its volume of production, cultivated area and consumption in the daily diet of the population, is of vital importance in the economy of the Latin American country. In Colombia, it is the third agricultural product in extension after coffee and corn. It represents 13% of the country's harvested area, being the base of popular food and the cheapest source of protein. The cultivated area of this cereal in the country is estimated at about 546,000 hectares per year, with an average yield of between 5 and 6 tons per hectare and a national production of about 1,570,000 tons. In Colombia, the main departments responsible for producing rice are Casanare, Meta, Tolima and Huila, where about 70% of the national production is concentrated. Farmers in these regions have to face different problems that arise during cultivation. From the nursery to final maturation in the field, the presence of insects, pests, virus transmitters, diseases that damage leaves, stems and grains. Added to this are the low fertility of some soils and poor crop management. Technology provides currently a scenario in front of the way to grow rice in a more efficient, economical and therefore profitable way. The adequacy of the soil is an important task for rice planting. A good establishment of the plants and better conditions for irrigation management and weed control depend on it, considering that it is a highly demanding crop of water per cycle. A conventional variety of rice consumes 350 and 300 milliliters of water per day. Land leveling contributes significantly to reduce water consumption at the field level, allowing savings and rational use of this resource. Previously, land leveling was done with the use of high-power heavy machinery, but shovels and implements whose precision has been perfected in agricultural tractors have already been designed. The incorporation of advances in laser technology and computing and improvements in mechanical design allow today to have equipment known as laser ground levelers. We are in the municipality of Villa Vieja, in the village of La Victoria, on the farm of the agricultural engineer Patrocinio Torres Castañeda, who has a farm, according to today's technology. What it consists of: this consists in the lot being presented in the form of pools and also has a zero slope for all points, laser treated. Land leveling consists of modifying the natural or modified micro-relief, standardizing or smoothing it, maintaining the slope or changing it in order to improve and facilitate the establishment of the crop under irrigation. Its agronomic management and subsequent development. In the first introductions, this practice is associated with facilitating the management of water in surface or gravity irrigation methods and facilitating the drainage of the field in planting various annual crops. In addition to these benefits, the efficiency and effectiveness of other agronomic practices associated with the agronomic management of rice cultivation have also been verified. This work requires the use of a large amount of mechanical energy to remove significant volumes of soil, between 1 to 2 tons per cubic meter by weight, from cut areas and transported short distances, to filled or lower areas, following the general direction of the predominant slopes of the land. The slope can be modified from 0 to more than 5%. However, in fields where dense annual crops such as rice are to be planted, efforts are generally made to maintain the natural slopes or reduce them to a lower one, depending on the need that justifies the modification. In rice cultivation, due to the use of gravity irrigation methods with continuous flooding with a fixed or variable sheet, the work of leveling the land seeks to reduce the initial slope of the land to modify the minimum slope, with the aim of allowing adequate management of the depth of the flooding sheet. However, the volumes and the depth of cut are greater as it approaches zero slope, which produces an increase in the consumption of energy and machinery and therefore of the costs direct from the operation. What is the use of treating it when doing it with laser technology? In the first place, the hydric resource, the water resource, is easier. The investment is worth less, and with the weed control that is carried out in the crop at any time and quickly, it's easier. Because you have precisely laser technology. The water resource is vital in rice cultivation, so we can carry out controls quickly. Because if I apply a herbicide to control a certain weed and I don't have water, the control is very erratic, very bad. But if I have water, in the first place, the control is very good and cheap, the doses of the products go down. If I don't have water, I have to increase the dose of the product a little more. The efficiency I get with the fertilizers is very good, because the soil is completely wet and the next day I have to put the water on it and then it will be absorbed by the plant quickly. And you can see me, and if I am going to spend 20 packages, they can reduce it to 15 packages in a moment, because it is the efficiency and the development of the plant is seen at any time. Soil leveling produces a set of advantages that favor the production of rice under irrigation, promote greater efficiency in soil preparation and planting operations, allow more precise agronomic management of the crop, enhance the efficiency of application of inputs and the response of the crop. They contribute to the control of weeds, pests and diseases, to the management of irrigation with water economy and time savings, and facilitate the harvest work, among others. High-precision micro-leveling, although it can be carried out with the equipment or machinery used in macro-leveling, as well as the necessary intervention of the topographer as guiding support, differs because the precision of the cuts and fills is below 1 centimeter, that is, millimeters. This is achieved by incorporating specialized leveling equipment, shovels, scrapers or motor graders. With the incorporation of innovations from the use of the combination of laser technology and computing. This is known as automatic work depth controllers of precision. What this system does is improve slopes. It sweeps the land, improves the slope depending on what the farmer requires. If he wants leveling, it will be 0. It means that the surface will be totally level. As work and grace, like the pool table. Or if you want to give it a slope of 30% of 20%, give it a slight incline. For land that is very humid, it can have easy drainage. Leveling is done with successive passes of the tractor and the shovel or scraper over the field previously prepared, with several passes of drags, from 3 to 5 passes, or with another plowing implement that allows loosening the soil and facilitating cutting, transport and filling. For this it is necessary to have a slope of the design and knowledge of the relief of the area to be leveled. The soil preparation work is carried out before and during the leveling work to maintain a layer of loose soil, which facilitates the work of the grader. This brings different benefits. 1. It is the efficient saving of water, because it is spending less water than was used previously, in the traditional risk. 2. Better management of weeds, when there is good waterlogging or in good volume of water. Weeds do not make as much presence as when there is little water. 3. Better yield in cultivation. In rice, rice is a plant that needs a lot of water. With this system we are going to maintain very good humidity in the soil and it is going to last much longer. The plant will have a better response at the end of the harvest. The performance of the work in the field will depend on the work capacity of the bulldozer, the power of the tractor, the experience and skill of the operator, the irregularities and initial slope of the terrain, the texture and humidity of the soil, the slope of design and geometry of the lot to be graded. Rice is a grass that adapts to ecosystems where the land has poor internal and external drainage, a very low predominant slope and soils with a heavy texture, with a high content of clay, which creates limiting conditions for its use in the establishment of other crops. At present, the unit increase in the production of most crops is greater in crops that are carried out under irrigation than those carried out in dry land, about 1,000 kilos per hectare. Experience in other parts of the world has shown that the success of producers in irrigated agriculture depends largely on the good conditions of the land to distribute water evenly. Rice does not escape this conclusion.